All right, this video is on completing the square, but when you have a coefficient. And specifically a coefficient other than 1. So completing the square, and this is specifically for when a does not equal 1. So for our first example, we're going to take the quadratic in standard form. And the quadratic is 2x squared minus 16x plus 33. And we're going to go through that process of completing the square to get this parabola into vertex form. So we're going to start off the problem just like normal. We're going to take this number and move it to the other side so that we can have our blank to add our perfect square. And then this part is where we have one step that's a little bit different from normal. To complete the square, we can only do it with x squared. We don't do it with 2x squared. So what I'm going to do next is I'm going to take out the coefficient of the x squared. It's kind of like dividing out the GCF, but not quite, because you're not worried about the x's, you're only worried about the number, that coefficient. So if I divide the 2 from those two terms, I would get x squared minus 8x. And then I have that blank in there. So now I do the step like normal. I'm going to say that middle term divided by 2 is negative 4. And negative 4 squared is 16. So 16 is the number that completes the square. So now I have to think about, just like normal, if we added something to the right side, we have to add that same thing to the left side. But here's the other part where things are a little bit different. I didn't really add 16, I actually added 2 times 16. So I really added 32 to the right side of the equation, which means I have to add 32 to the left side of the equation. So now I have y minus 1 equals 2 times something squared. And if you remember, to get this into that completed square form, it would just be x minus 4. It's whatever the number is that you got when you divided by 2. And then we can go ahead and get that y all by itself. So again, we're in vertex form, but now this time we have a stretch of 2 as one of our extra transformations. All right, let's do another one. So for this one, we're going to look at what happens if you have a negative coefficient. So we have negative x squared plus 6x minus 5. Again, the first step is going to be to take that number on the end and move it over so that we can have a blank there. And then just like the previous problem, we're going to divide out that number that's in front of the x squared because we want to have x squared all by itself. So when I divide that negative out, that leaves me with x squared. Divide a negative out and I get minus 6x. And then I have the blank. So I'm going to do negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So 9 is the number that would complete the square. And then I have to make sure that whatever I did, I do to both sides. And this really wasn't a plus 9, it was actually a negative times 9. So I really subtracted 9 on the right side, which means I need to subtract 9 on the left side. So now I have y minus 4 equals negative of something squared. And in the parentheses, I would have x minus 3, because when I divided by 2, I got negative 3. And now I can go ahead and add the 4 back over. And so in the vertex form, I can see that one of the transformations is this parabola has been reflected over the x-axis, shifted right 3 and shifted up 4. All right, for this one, we're going to have a negative with a number. So again, the first step, we're going to take that number on the end and move it over to the other side. And then just like before, we're going to go ahead and divide out that number that's in front of the x squared. So that leaves me with positive x squared, and then 12 divided by negative 2 is negative. And then we have our blank. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So 9 is the number that completes the square. But I didn't really add 9 on this side. I actually did negative 2 times 9, which is negative 18. So I really subtracted 18 on the right side, which means I need to subtract 18 on the left side. So I have y minus 1 equals negative 2 times something squared. And in the parentheses, I would have x minus 3. All right, I want to do one last example because sometimes you will have an a value that's a fraction, and a lot of students make little mistakes with those. So I want to do one of those, and then that will be the last example. So for this last one, we're going to say y equals 1/2 x squared minus 4x plus 12. And so first up, just like the others, I'm going to minus the 12 over. And then just like the others, the number that's in the front of the x squared needs to be divided out. Now, when I do 4 divided by 1/2, a lot of students are going to be like, oh, that's 2. And that's not how dividing by a fraction works. When you divide by a fraction, the number actually gets bigger, not smaller. So when you say 4 divided by 1/2, it's kind of like saying if you have 4 cups of flour, how many 1/2 cups of flour is that? And if you think about that, that would be 8. If you have 4 full cups, that would be 8 halves. And so when you do 4 divided by 1/2, you get 8. You can also do that in a calculator. So if you want to type it in, you would say 4 divided by, and then the 1/2 you have to put in parentheses. So 4 divided by 1/2 is 8. All right, so dividing by a decimal actually, or a fraction that's smaller than 1, actually makes the number bigger, not smaller. And then we have our blank there. So I have negative 8 divided by 2 is negative 4. Negative 4 squared is 16, so 16 is the number that completes the square. But we didn't really add 16, we actually added 1/2 of 16, which means we added 8 to the right side. So since we added 8 to the right, we're going to add 8 to the left. And so we have y minus 4, and then this would be x minus 4. And that's because when we divided by 2, we got that negative 4 right there. And now I can go ahead and add the 4 to the other side. And we're done.